Solve systems of linear equations using the addition method. The addition method says we are going to add both equations together and eliminate one of the variables and solve for the other. So to start, we have two equations, x plus y equals 7 and x minus y equals 5. Our goal is to add these together and eliminate one of the variables. Notice that the y's are one's positive and one is negative, and they will automatically cancel out when we add these together. That's our goal. So we're going to add our x's. 1x plus 1x is 2x. Put down your equal sign. 5 plus 7 is 12. Now let's solve for x by dividing both sides of the equal sign by 2, and we get x equals 6. Now that we know what x is, we can plug it back into either one of the original equations. It does not matter which one, just pick one. I am going to use the first equation, and I am going to replace the x with a 6, and then solve for y. 6 plus y equals 7, so I'm going to subtract 6 from both sides of the equal sign, and that gives me y equals 1. Now when you solve for a system of equations, what you're really looking for is the intersection of the point. If you were to graph the two lines, you would be finding that point of intersection. And that point of intersection has coordinates x, y. So in this problem, our solution is the coordinates 6, 1. Set of coordinates for the point of intersection. Another example, 2x plus y equals 7 and x plus y equals 3. Now, when you're solving systems of equations with the addition method, you always want to keep your x terms lined up and your y terms lined up and your constants on the other side of the equal sign. Make sure you have that first. Now, this problem, if I add these together, my x's don't cancel and my y's don't cancel. So that means I need to change one of these. I can either change one of the y's to a negative by multiplying the entire equation by -1, or I can change the x to a -2 by multiplying the entire equation by -2. Doesn't matter which one you want to eliminate, just pick a variable. I'm going to eliminate y, and to do that I need to multiply the second equation by -1 so that I'll have a positive y and a negative y. And that gives me -x minus y equals -3. Make sure you multiply that -1 to all three terms, both sides of the equal sign. My first equation does not change. That stays 2x plus y equals 7. Now I can add them together and my y's will cancel out. 2x minus x is x. 7 minus 3 is 4. Now that I have x, I can go back to either one of the original equations and plug 4 in for x and solve for y. I'm going to use the second equation, x plus y equals 3, and replace that x with a 4 and solve for y. So I need to subtract 4 from both sides of the equal sign, and that gives me y equals -1. So my solution to the system of equations is the set of coordinates 4, -1. Two more examples. In the first one, x plus y equals 7 and -x minus y equals -5. When we solve this one, both variables cancel out, giving us 0. But on the other side of the equal sign, we have 7 minus 5 equals 2. 0 does not equal 2. This is a false statement, and therefore there is no solution. false statement, no solution. On the next example, when we add these together, both are variable terms, the x's and the y's all cancel out, leaving 0. But on the other side of the equation, 14 minus 14 is also 0. This is a true statement. True. That means infinite solutions. No matter what values you plug in for x and y, you will always get a true statement. So there are infinite solutions. Another method to use for solving systems of equations is the substitution method. We use the substitution method when we have one of the equations already solved for a variable, as in y equals 2x. Notice the y is by itself. So if y equals 2x, we can replace the y with 2x in the other equation and solve for x. And that would give us x plus 2x equals 15. Combine like terms, x plus 2x is 3x equals 15. And now divide both sides by 3. X equals 5. Now that we know what x is, we can plug that into the other equation and solve for y. And that will give us y equals 2 times 5, y equals 10. The solution to the system then is the set of coordinates 5, 10.